welcome to this introduction to forces, where we find out exactly what forces are and what kinds of forces we will be investigating in this class. We have spent the first 3 chapters looking at kinematics, or how objects move. We've been able to use the kinematic equations to explain this. Now we will be looking at dynamics, or why objects move. It is this combination of kinematics and dynamics which make up mechanics, and that is what we will be discussing in this chapter. To understand dynamics, you must first understand forces. Now you may remember that a force is a push or a pull from earlier grades, but there is more to it than that. A force always acts on an object, and a force is always caused by an agent. It is this duality, this combination of object and agent, that makes up the interaction that we can use to describe a force. Forces are always vectors, and that brings in several things that we can use, such as force includes both magnitude and direction. We can also use vector diagrams to describe these forces. We can take 2 perpendicular forces and add them up to create a resultant force, and find both the magnitude and direction of that resultant force using the Pythagorean theorem and inverse tangent. Finally, we can take a force that is directed at an angle and break it down into its 2 horizontal and vertical components using sine and cosine. Finally, forces can be classified as either a contact force or a long-range force, and we will investigate both of these types during this chapter and later chapters. For the remainder of this video, let's look at several types of forces. First, we will look at weight. Weight is the force of gravity acting on an object. Weight is a fairly special force because it is always directed downwards. No matter what direction the object might be moving, up, down, or around, weight will always be directed straight down. It is also important that you realize that weight is not the same thing as mass. We will investigate mass in further detail later in this chapter. The spring force occurs whenever you push or pull on a spring and the spring pushes or pulls back. Below you can see a spring assembled on a table, and as the spring moves back and forth, you can see the spring force that is always pointed in the opposite direction from which the spring is moving. We will discuss springs in a later chapter. The tension force occurs whenever you pull on something with a rope, string, or other flexible material. The tension force is never a pushing force. It can only be a pulling force. The normal force occurs whenever any object is pressing against some surface. Here we see a flower pot sitting on a table. The force of weight is acting down from the flower pot, and the table exerts a force back upwards on the flower pot, and that force is its normal force. Notice the normal force is always perpendicular to the surface. The perpendicular property of the normal force applies even when the surface is at an angle, such as with this ramp, and you see the normal force is applied perpendicular to the ramp surface, or if the surface is straight up and down vertical, such as this man leaning against a wall, and the wall exerts a normal force perpendicular to its surface. A force which we have ignored up to this point is friction, but now we're going to start taking it into account. Friction is the parallel force between a surface and an object that is moving across the surface. There are 2 types of friction. One is kinetic friction, which is a force that opposes the motion of the object that is sliding across the surface. Here you see a block that is sliding, and the force of kinetic friction points in the direction opposite of its motion. The other kind of friction is static friction. Static friction is a force of friction that prevents an object from beginning to slide. For example, here you see this small mouse trying to push a block, but the force of static friction pushes in the opposite direction. Drag is a force that we will not concern ourselves with much, but it's the force that opposes or resists motion through a fluid, such as liquid or gas. The drag force you are most familiar with is air resistance, which we have ignored up to this point and will continue to do so. Another force is thrust, which occurs whenever gas or some other fuel is expelled out of a jet or a rocket. The direction of the thrust is always opposite the direction of the expelled gas. 2 other long-range forces are the electric and magnetic forces, which we will investigate later in the year. That ends our introduction to forces. Next up will be Newton's 3 laws of motion.